Good afternoon, everyone. Now we are starting our today's session. At this point of time, I am seeing very less number of participants over there, but this session will be recorded and will be on the YouTube also. So the time is already 3:02, and the session start time is 3. So I am starting the session. Okay. So first of all, I start with my introduction, and then I go ahead with what are the content what I that I will discuss today. And I will also revise the last session in a very quick manner. Afterward, I will move forward. And, uh, and those participants who are going to watch on YouTube link, and they will also get benefited because a quick revision of the last session will be provided. Okay. So first of all, my name is Sumit Kumar, and I am PMRF research scholar at IIT ISM Dhanbad, and this course is the Geotechnical Engineering 2, and this is taken by Professor D.N. Singh sir from IIT Bombay. Uh, I am a TA under him in the NPTEL course, in which I am elaborating those concepts. And if any one of you have some doubt, I am trying to clarify it over here only. And that's it. And for the additional information, this content which I will going to discuss today will be shared with you by the NPTEL team. If in any case, if it is not reached to you, you can text me over here as well. I will try to provide those link at this point of time only, but I think so it will be shared with you. Okay. And one additional point I want to mention that if due to some network issue, if call get disconnected at some point of time, don't worry, stay in the meeting. I will rejoin and start from the meeting that from that point only. But that is not going to happen. But if in any case that is going to happen, please stay in the meeting only. Okay. So I also want to mention some additional points over here that we are discussing the geotechnical engineering too. So first of all, we will start the revision of the last week lecture only. In first 5 or 10 minutes, I am going to take that because there are very less number of participants at this point of time. So in that time, we can utilize in the revision. Afterward, I will start the new content. Okay, so I am sharing my presentation with you. I think so my screen is visible for all of you. If at any point of time anyone have any problem with audio and video, you can text me at any point. Okay, now I am starting and some of the point of revision from the previous lecture. Afterward, I will go ahead with new content. Uh, okay. So in the last lecture, what we have discussed, I am going to give you a very quick revision in the first 5 to 10 minutes. Afterward, we will go ahead with the new content which I have prepared for you for this session. So now let's start. So in the last session, we start with the shear strength of soil. We have discussed that what is the shear strength, how it is important, what is its significance, and how it helps the common persons, common technicians, common engineers, the civil engineers in geotechnical engineering in helping the various aspects in the designing the foundation as well as protecting the slopes from getting damaged. Okay. We also discussed some of the factors which are interlinked with that is the cohesion and the angle of internal friction, that is the important parameter over there. The cohesion represents the shear strength of the soil particle due to the intermolecular force of attraction, and similarly the angle of internal friction represents the resistance of soil particle, and those are the independent in its own way. Like cohesion is a important factor in the cohesive soil, while the angle of internal friction is most significant in the non-cohesive soil, that is sandy soil. But it is not always the case that we find only clay soil or only sandy soil. We always find C5 soil. So we need to take care of this. And we will discuss those points, some of the problems where when we go to test, which we are going to discuss today only, the what are the content which is going to discuss today. So we will go over there. So I am taking these points very quickly uh, in first 10 minutes, and afterward the new content is getting started. And because there are less number of participants, so I try to utilize this time with you by revision of the last lecture. Okay. So the different type of test, I have already said that some of the tests which are the primary two tests we are going to discuss today, that is the direct shear test and triaxial shear test. And some of the small problems are also there which are we are taking today, and in subsequent chapters we are taking some of the very good problems on this topic that will help you in understanding the practical implementation of these terms which we are studying right now. Okay. So as I already said that the importance of the shear strength in the geotechnical engineering is very large extent. So we need to be very fair. And we need to be very concerned about the shear strength of soil and how it affect the characteristics of the superstructure or the substructure foundations which are situated over there. We also see that how the shear strength is relevant, that the soil has some strength, and when the stress act on it due to any other factor, suppose due to earthquake, so the soil gets filled from a specific portion. So what is that specific portion? Basically, I show you some images as well in subsequent slides. So these points already discussed. So I am giving the quick revision only. Shear strength of granular soil and shear strength of cohesive soil as the different consideration. As I said that the cohesion is due to intermolecular force of intermolecular force, but while in cohesionless granular soils, the behavior is quite different, and it is due to the rigid boundary conditions and many more things. Okay, so what I am discussing right now is the how when the shear failure takes place. Shear failure takes at that point when the critical combination is achieved. You can see the diagram over here. In this diagram, you observe that the failure take place. The detached body is at the right side, while the parent body at the left side. The detached body detached from the parent body is due to some reason, and that is the reason that the shear stress acting on that point is more than the shear strength at that point. So, okay. So I think so. Some of your earphones, microphones are on. So please check. Everyone keep off their microphones, so there is no noise over here. Okay. So the parent body and the detached body, the two of the sections shown over here, the detached body get removed, and the failure takes place from this portion only, and this is only due to this condition arises only because of this is the critical combination. This is the section where the stress applied is more than the strength at that section. Okay. So you can see the practical example as well. Here the detached body is shown. The sections which is cut off from the parent body is shown over here. The parent body remain stable there, but the failure takes place from this section only, and this is due to this is the only reason that over here the section is the most weakest. That's why failures take place over here. Okay. So the another image also demonstrating the same. So I am going very quickly because we are not in discussing this today. We have already discussed this last week, but I am giving the quick revision for you. Okay. So the triaxial state of stress, we already discussed that the stress acting at the any point in the three dimension. But when we do the analysis, the 2D situation is considered irrespective of 3D situation. Okay, 1 minute. I have to check someone's earphone is on, so it will be disturbing me at this point of time. Okay. Okay, I will go ahead. So the tricycle state of stress, what I am discussing, that the stress is acting at any point in the three dimension, not only in two dimensions. So it becomes very important that we have to be aware about that. We are taking the consideration of two dimension only, but the force stresses are acting in the three dimension. But it is a like plane strain problem where the third dimension, the strain in the third dimension get ignored. Basically, it is of infinite length in a way. So we consider the two-dimension cases in the civil engineering, specifically in geotechnical engineering, and that serve the purpose for us. Okay. So we have derived the sum of the relation between the shear stress and the normal stress, which can be found at any specific plane which is inclined at some angle from the given state of stress. So those are the relations which we already discussed in very detail, and we have also shown that what are the Mohr circle and how it can help in finding the major principal stress and the minor principal stress. On the shear plane, what are the shear stress, and on the other plane, how we can get the normal stress and the shear stress. Okay. So moving ahead, the Mohr circle is the most important factor, and for the Mohr circle, the property of Mohr circles are also mentioned over here, and there is a sign convention for the Mohr circle, which is one of the important term which need to be considered, because if you are not going to consider these things, then during the solving the problem either by the analytical method or by in the Mohr circle method, you get confused. You may take the plus suppose a shear stress of 20 kilonewton is acting at a specific section, you take minus 20 respective of that. So the sign convention is important. You will you have to consider, you have to take the signs significantly. Otherwise, your result will get opposite result. So, and specifically, if any one of you are preparing for any competitive exam, they frame the question in that way that you'll get the wrong answer, and after the exam, you feel happy that the question is very easy. And when the result comes, you suffer that what the blunder I have committed. So, be aware of that about the sign convention in any subject, either in the soil mechanics or in the strength of material. When you are taking this topic or any topic where the sign convention is there, you have to be very aware about that, because those are the things, those are the points where the examiner test you that whether your concept is clear or not, because it is a big mistake many of the students are committing over the at the several occasions it has been seen in specifically in the competitive exams. Okay. So moving ahead, the general solutions, generalizing, we have generalized the solutions for the tau and sigma. We also have solved the sum of the problems. In the Mohr circle analysis, we have discussed that they are the principal major stress and the principal minor stress. And the principal major stress and the principal minor stress are one of the important terms. Which needed to be taken in such a way that when we calculate the major principal stress, minor principal stress, we can found the stress at any angle from that plane only. Which for that there is a question also taken during the last lecture, which is also over there in the presentation, but that I am not going to discuss at this point of time. You can go at the YouTube and go with the video, and you will get those links from the NPTEL team. And if not, at the end of the discussion, I will ask the question. Then I will provide in the next meeting in the message box that these are the links from which where you can access the PowerPoint presentation as well as the lectures videos. Okay. Moving ahead, the Mohr circle. This is the most important circle which I have discussed, which I have taken approximately 10-minute times or 15-minute time in discussing during the last lecture. So you must be aware about that. These are some of the important points, the basic questions which can be solved, and some of the advanced questions can also solve if you understand that how to obtain the center of the Mohr circle, how to obtain the major principal stress, how to obtain the minor principal stress. So over here, everything is pointed out that the sigma 1 is the major principal stress and sigma 3 is the minor principal stress. The horizontal axis is the zero shear plane, while the radius is the shown as A, and how sigma square plus tau square become A square. This has been taken in very detail. I think so. You will be very familiar with this, and I also give you some task which is the voluntary, but I think you must go with that, and you found it helpful, and you will understand more thoroughly if you have gone through them. Okay. So this is the relations which by which we will find the major principal stress and minor principal stress on the any other on a plane where the stress in the horizontal and vertical direction is known and the shear stress is also known on a certain plane. Then we can able to find the major principal stress and the minor principal stress. And one of the another term which I have discussed when I had taken the question, it has been also shown that the sigma p1 plus sigma p3 is equal to sigma x plus sigma z is justified over there. And to find at what angle it is acting, there is a relation also over there. Okay. So moving ahead, we will go forward in the direction, and we have solved some of the problem. I think so that will be discussed in the very elaborated way, so you will understand those things. And I also told you that take your own example and solve the problems like this. You will get more familiar with such problems. So I will skipping this part and moving ahead. Okay, and the application in civil engineering. Okay, today also we are going to see the applications and how it will prevent the damage during the earthquake. Those aspects are taken into account in the today discussion. The PPT which is prepared for today. I'm discussing the previous PPT in a quick manner for you. Okay. So sigma 1 and sigma 3. Sigma 1 and sigma 3 as sigma x and sigma z, it is already stated in the presentation over here. And when the sigma x is greater than sigma z, the passive state of material, and sigma x is less than sigma z, it is the active state of material. And how it is happening, that is will be understood like when the if you are aware little bit awareness about uh, the if the soil if the certain retaining wall is moving toward the soil, the horizontal stress get enhanced, while if the uh, wall is moving away from the soil, the vertical stress is more. So the term which has the more stress is shown as when the passive state of stress, the wall is moving toward the soil. So that is represented over here. That will be taken in the more elaborate way when we study the topic of the active stress, passive stress, and those terms. Okay. So pole is already discussed, and it is a very basic things. Basically, pole is nothing but the mover circle through which all the plane will pass. Okay. The generalized state of stress is the interrelation between the tau and sigma with the sigma x and sigma z. And this is the question which had been discussed in the class. The question is given by the sir. Then the solution of that problem is shown over here. And these are the some of the more problems which I have discussed in very elaborate way in the last video. If you are there, you must understood. If not, you can go on the YouTube link which is provided to you. You can understand those things. There is no problem in that. So I will move ahead. I will skip this point, and I will start the new discussion which I have prepared for you. Okay. So I am going to start the today discussion, the new PPT. I think so. Most of the people have joined who are willing to. So I will start the discussion from here with the new presentation. Now I am sharing the new presentation that will contain the new content which is not earlier there. I think so. Screen is visible. Yes, I have seen. It is visible. No problem. Okay, so this is the content which I have prepared for you for the week 2, and this is the Geotechnical Engineering 2, over where we are studying first of all the shear strength of soil. Today we primarily discuss the different type of tests are there for the shear strength, and we will discuss the direct shear test, that is the box test, and the tri-axle test in the little elaborate, and we will also take the some of the problems. But today the problem might be limited, but in the subsequent class, specifically in the next class, we will take some more problems that will give you idea about the practical implementation of the theoretical term which you are going with at this point of time with me. Okay, so we will go ahead. So first of all, the Mohr Coulomb failure criteria. This is the same things from where we have ended in the last lecture. So, here you can see that there is a relationship between the shear strength, cohesions, and angle of internal friction. Over here, you can see that the shear strength is nothing but the function of effective shear stress, and the effective shear stress is one of the most significant terms which you have gone through in the geotechnical engineering one. Effective stress is the most important term. Why? Because in effective stress we have considered the effect of water present in the groundwater table. So if you ask any geotechnical engineer now, then you say what is the biggest problem in designing any substructure? He said that the water is the biggest problem for me. Basically, water is the enemy for the geotechnical engineer or specifically civil engineer as well who are going to take that aspects of things in the designing. So, we always consider the effective stress. Earlier, there is a case study there that when the effective stress is not used, instead of effective stress, we use cohesion plus total stress into tan phi. The several structures are designed on that only in a very earlier time when these concepts are not too much examined. So in that case, those structures are seen damaged. Afterwards, the more research are done and the modified more Coulomb it suggested that we will consider the effective stress parameter C dash and phi dash instead of C phi, and the sigma will be the effective stress. We will take those points in very elaborate term when we go to a triaxial test and we solve the triaxial test problem. We will understand those points in a very good manner. Okay, so we are going ahead from here. And this is the graph which I have discussed that here see the cohesion and the angle which with the horizontal this plane is making. There is in a subsequent slide more elaborated uh, diagrams of these things is given where you will understand those terms in a more precise manner. Okay, so here is the term which is showing that S equal to C plus sigma dash tan phi. Here C and phi is also the effective parameter, effective cohesion and friction parameter. Okay. So again, we start with the definition of T term, and then we will go ahead in a forward direction. After that, you will understood those terms, and you must be enjoying the today lecture. I think so. Okay. So first of all, and what is the shear strength? The shear strength of a spile is the maximum internal resistance applied to shearing force. The shear resistance is against the shearing force only, and you must understood this point that the shear strength is the strength of soil. The stress which is applied above that strength result in the failure of the soil surface. And as if you remind the previous the revision which I have give you today, over there also shown that when tau is greater than tau critical, the failure takes place, and the failure takes place at the critical combination where the shear strength is the minimum. Over there, the shear strength is less than the what is the shear stress applied at that point. That is that critical combination will result in the failure of the soil surface. Okay. The effective friction angle is the measure of the shear strength of soil due to friction, and due to friction, this is the predominant term in the cohesion-less soil, irrespective of cohesive soil. While cohesion is the measure of intermolecular forces, which intermolecular forces between the particles will be the cohesion. Okay. Now we are talking about the apparent cohesion. Apparent cohesion is apparent shear strength. Apparent cohesion is apparent shear strength at the zero normal effective stress, and you will come across afterwards if we are going to the foundation engineering. Over there you have see the term like mobilized cohesion. That is a different thing, but you will understand those terms in a subsequent point. And dilation is the property in which the change in volume takes place. If volume get expanded or get changes in any due to any region, due to the fill of voids, due to water. That is the time when the dilation takes place at that specific location. Okay, going ahead. Now we will again start with the shear strength definition, which we already discussed in the last class. So first of all, the define shear strength of material. So as already discussed, the shear strength is the strength of soils after which, if the stress get enhanced to that point, if we see the practical example, suppose 20 kilonewton is the strength of shear strength of the soil. If the 19 kilonewton is applied at that section, it will remain stable. But 19.5 it will remain stable. 19.9 it will remain stable. 20 it will the at the verge of failure. But when we increase the from 20 to 20.1, 20.2, it will get failed. But you should understood that whenever we design the any structure, we also consider the factor of safety. But the practical example, if we take the example in the term of numbers, this way it will act. Okay. So now what I have written that the shear, the detached body and the parent body example, which I already shown in the earlier section of today presentation of the previous class, you have seen that how the detached body get detached due to the critical section. The over that section, the shear strength of soil get shear stress of soil is more than the critical shear strength at that section, resulting the failure of the soil from that portion only. Okay, so the weakest plane, basically that plane is the one of the weakest plane. That is why the failure takes place from there only. Okay, moving ahead, the factor influencing the shear, the major factors causing the shearing is the earthquake. One of the major factor, not the major factor, the landslides or many things you can see that takes place specifically in the mountainous or in plain region. Also, sometimes you see that earthquake will result in the failure of some of the retaining walls or some of the small slopes also get failed due to the earthquake. So one of the important factor that will cause the shearing, and what earthquake can do, everyone know, but earthquake can increase the relative motion between the soil layers, and that will enhance the chances of the shearing failure of the soil. And we know that there are several faults are present in the earth. So fault causing one portion of the ground to slip down over the other, and that will ultimately lead to the shearing of the soil sections from that point. And the understanding the state of stress during the shearing is also very crucial for the stability assessment. If you are accessing the stability, if any structure is designed, we are also always concerned about whether it will remain stable in the critical condition. Critical condition means the adverse condition. So the stability considerations also need to be considered, taken into account for the adverse conditions, like during the heavy rainfall, specifically in the hilly region, or during the earthquake. Some of the other factors which are also of the prime importance is the slope instability, and during the construction activity you also see that some of the factors are there that will cause the that will cause the shear failures over there. Okay. Some of the applications, there are various significant applications are there in the engineering you came across in day-to-day practices, specifically when we consider the geotechnical projects. We see that it has shear strength has most of the most important term when we go in a geotechnical engineer. Shear strength analysis help in designing the foundation, retaining wall, and slopes. Obviously, you came across in day-to-day life, day-to-day news. You see that at some places, specifically in the rainy season, recently you have seen in Himachal or Uttarakhand or in the mountainous region, northeast region, you see that several landslides takes place due to the heavy rain after the heavy rain. So So that takes place only because the strength over there, the shear strength of the soil is not up to mark to sustain and those soil mass, those slopes in a stable condition. So that become very important to understand that what is the shear strength, what will be changes in the shear strength during the adverse condition like during the heavy rainfall or maybe during the earthquake. So, shear strength is the most important term in assessing the stability of the natural or man-made structure. बिल्कुल. In the natural structure or the man-made structures, both need protections from the failure due to shear. So the construction which we are preparing, we are trying to stabilize some slopes. So we should be very aware of the fact that it will remain safe in the adverse condition also. And the incremental changes in stresses lead to shearing. It has been seen that the change in stresses lead to the shearing. So we should be aware about those facts also. Okay. Going ahead, the shear strength of soil. The shear strength of soil, again, it is a definition term only which is written over here for you. At the shear strength of soil, the soil consists of the individual particles that can slide and roll relative to one another. And how sliding and rolling is significant in the angle of internal friction is discussed in the last class. And shear strength of soil, or in the last class, you also have gone through the video over there. Also, there is a good discussions on that point that what is the rolling and sliding help or can cause the internal friction. The shear strength of soil is equal to the maximum value of shear stress that can be mobilized within the soil mass without the failure taking place. Exactly. You understand this point very easily that the soil has some shear strength and the shear strength of soil is equal to the maximum value of shear stress that it can be mobilized. Means what is the maximum value of the shear stress it can sustain is the shear strength. The example which I already given that suppose the example of the if suppose the soil has a strength of 20, so it will sustain at 19.9999 kilonewton up to 20 kilonewton as well. That is the critical combination. But if the stress get increased from 20, it will result in the failure. The practical example is this only, but in the factor of safety we are not taking into consideration over here. If we have provided we have designed certain slopes for the stability. Okay. So the shear strength of the soil is the function of stress applied to it. You have seen the basic term Mohr Coulomb criteria is equal to C plus sigma and tan phi. So the effective stress, the shear strength is the term which is related to the stress. That is the effective stress when we consider the modified Mohr Coulomb theory. We will see those points as well. First of all, today we are primarily focused on the test. The what are the different tests we are going across, but we are discussing the two tests in little detail. That is the direct shear test and the tri-axial test. Okay. So the it as well the manner in which these stresses are applied. The knowledge of shear strength of soil is necessary to determine the bearing capacity of foundation, the lateral pressure exerted on the retaining wall, and the stability of the shear strength is very important. Very important. Basically, you have to go across in any places. In any construction, the foundation is there and the shear strength of soil is necessary in determining the bearing capacity of foundation also. So any structure when we are designing the shear strength become the most important factor. When we see that the lateral pressure exerted on a retaining wall, you have seen that there are the several expressway or highway are there which are constructed at some specific height. On that places also the retaining walls are constructed to increase the height over there and to sustain the load within them. So in that case also the shear strength becomes the one of the most important parameter. Apart from that, the slope stability in hilly terrain, the slopes are there. If we try to design it some construction over there, so we take care of the stability. If we are constructing some of the infrastructures at those places, so how it will remain stable in any adverse condition. So on those aspects also the shear strength is one of the most important criteria. Moving ahead, the Mohr circle of stasis. The Mohr circle of stasis has been understood by you that what is the principal stasis, what is the principal major stress, what is the principal minor stress, how we will calculate the center of the Mohr circle, how we calculate the principal stresses into sigma x and sigma z are known, or the shear stress is known at certain plane. What are the different value of the normal stress and shear stress at specific plane is also over there, which you will understood with a good extent during the previous lecture. Okay. So the vertical plane, I will read this for you first of all, then I will elaborate the subsequent section. In soil testing, the cylindrical samples are commonly used, in which the radial and axial stress act on a principal plane, and the vertical plane is usually the minor principal stress. It is written usually, not always. What I have discussed about the active and passive. During the passive, the horizontal stress are the major, while the vertical are minor. We will go into that as well in today only. Some of the problems are there, but that is not the altered problem. That is direct problem. So you found you might not found those interrelation, but you will look into that. Don't worry. Okay. The radius here is the minor principal stress. The radial is nothing but horizontal, while the axial here which is acting along the axis, that is the vertical, is the major, which is shown over here from this diagram also. That is the axial shear stress acting from the vertical upward and downward direction, while the radial shear stress is shown in this in this representation for you. Okay. Moving ahead, the Mohr-Coulomb failure criteria. First of all, we have started with the Mohr-Coulomb theory. Over there, we have mentioned that the Mohr-Coulomb is important, one of the important aspects that how we relate the effective stress with the shear strength of the soil. So, the when the soil sample has failed, the shear strength on the failure planes define the shear strength of the soil, and the field on the field what at the failure plane from where the soil gets failed, at that point what is the stress acting at this at that situation, which is the shear strength of the soil at that point. So it becomes very necessary to identify the failure plane. And failure plane, as shown in the image earlier, you have seen one of the image in that you have seen that the failure takes place from the specific point. The soil body is there in the right and leftward side of that section only, but you see that the failure takes place from one specific section. So that specific section is the critical combination where the shear strength is minimum in that specific plane, so the body get detached from that plane only, not from any other places. So the plane on which the maximum shear stress act, or the plane where the ratio of shear stress to the normal stress is maximum, is the plane where the failure get increased. Okay. For the today discussion, for the this discussion, it can be assumed that the failure plane exists as it is possible to apply the principal stress and measure them in the laboratory by conducting triaxial test. When we go ahead with the triaxial test, you came across that how we will apply the stress from all the direction, how we are applying the radial stresses, how we are applying the axial stresses, that will ultimately result in the conclusion of the that will ultimately result in the finding of the results. Okay. Now, the some more point about the Mohr Coulomb failure criteria. The Mohr circle of stress at the failure for a sample can be drawn using the known value of the principal stresses, and the several tests are also there which we are going across, but we are discussing only two tests in elaboration, which is required over here for this course. And it is conventional to show that the upper half of the Mohr circle, exactly the upper half of as a circle drawn, it is not necessary to draw the whole circle for us. The upper half of the circle, the symmetry is along around the horizontal axis. The circle which is drawn over the upper sections of the axis will be similar at the downward section as well. And the line tangent to the Mohr circle can be drawn, and that is the Mohr Coulomb failure envelope. And the Mohr, what is the Mohr Coulomb failure envelope? The envelope which is formed by the drawing of the Mohr circle will result in a straight line. The any stress point which is acting below it will remain safe. The up to that the strength of the soil is there, but if any point going above that, here you can see that the more column failure envelope, the more circle get drawn, and when the stress get increased at this point, also the point which is touching the more column failure envelope, the stress at this point, the tau and sigma, which is at this point, is the critical combination where the soil gets filled. Okay. So this is the more Coulomb failure criteria envelope significance. How we draw with the help of stresses will be elaborated in coming subsequent slides, coming classes also. And so some more point about the more Coulomb criteria is like if the stress condition for any other soil sample is represented by a Mohr circle that lies below the failure envelope, what I have said earlier, that is only written over here. If the failure envelope, every plane within the sample experiences a shear stress which is smaller than the shear strength of the sample, and thus the another point which is mentioned that the point tangential to the envelope of the Mohr circle at the failure gives you the determination of the inclination of the failure planes. That is the tangent. The this point also, the if you are able to see my the arrow of my cursor, you can see that at this point also the failure takes place. At this point also the failure takes place. But any point below this more column failure envelope, there is no chance of failure, as well as any sections above it also will not result in the failure. Okay, moving ahead, and these points are already taken. Now, some of the important aspects you can see from this image as compared to previous image, that when we draw a failure envelope, will find you will find that there is a phi angle is shown over here. This phi is nothing but angle of internal flexion, and the line which cut the y-axis at a specific point is the cohesion. How we will find it, how it came to us will be elaborate. Okay. So now we will come to the different type of test which we came across in day-to-day life for the shear strength is now presented to you. So the sum of the test, the most popular test is the shear box test. There is nothing but the direct shear test. The triaxial test, that is the most popular, and that will give the most one of the best result. Not I will say that the every test has some limitation, but the triaxial test is one of the predominant test which will almost represent the true behavior of the soil. We will take in detail these two tests. Another test are the vein shear test, taut shear test, flat jack test, and the penetration test. So we will go with some points one by one for every test. Afterward, I will discuss the first of the two tests in more elaborated way, and that will be very helpful for you in my point of view. Okay. So first of all, the shear box test. The shear box test is a 2D simulation of the soil condition, and it provides a plane stress representation of the shearing behavior. As in this test, the failure plane is predefined. We know that from where we are going to fail the soil. So it has the several limitation as well. It will not represent the real 3D condition. Basically, in any soil section, the stress acting from all three directions. It is a different thing. We have calculated the 2D simulation, that is sigma x, sigma y, and we calculated the sigma and tau for that. But the stress is acting from all three directions. When we go in the triaxial test, the stress acting in the radial direction all across, that is the two direction if we consider in a 3D plane, and the axial stresses come from the vertical direction, so it will consider the overall aspects of the section. Moving ahead, in the triaxial test is the second test. It is the 3D description, which is explained already by me, and it is a better replication of site condition. Basically, in site also the stress, if we consider the specific section in the soil, the stress acting at that point is from the three direction, not from the two direction. So it represents the practical implementation. Suppose take a hypothetical example. Suppose a specific soil section situated at x meter below the soil. So at that section, the stress acting from the vertical direction will be different, but the stress acting from all around the horizontal direction, that is the radial direction, will must be same. So that condition will be implemented in the triaxial test. We will go into that, and you will see that how this will taking place. Now, it will help in understanding the soil behavior under the more complex condition. The more complex condition is that like actual condition, more or less. More or less, it is the actual condition only. And another test is the Valencia test, and it is also one of the popular tests which will be used in day-to-day life, and it is used mostly for the soft and sensitive soil because there is a torque is provided to move the Valencia apparatus, and it has the application in laboratory and the mostly laboratory, and it is also used in the field setting as well. The both apparatus are there with us, and it is quite useful in the test of the shear strength in the offshore environment. Um, to measure in situ shear strength, it is difficult to sampling the situation. Basically, taking the sample to get the strength is one of the difficult aspects of this test as well. Another some of the tests are the torr shear test, that is also similar to the more or less vein shear test. And moving ahead, the flag jack test is the another test. Now, the last test which we use in field to get the shear strength of the soil is the penetration test. In penetration test, we access we try to access the substrata, substrata of the foundation, that how it will be there, how what are the aspects over there. The different type of penetration test, including SPT, standard cone penetration test, standard penetration test. Those are the some of the tests also there, which will help in understanding the uh, behavior of soil, strength of soil over there. And this test provide the information about the shear strength properties of material of the soil. Okay. Moving ahead. Now, what I have already told that we will discussing these of the two tests in the more elaborate way. That is the direct shear test and the tri-axial test. So first of all, we will go with the direct shear test. Afterward, we will take the tri-axial test into our consideration. The direct shear test is that test in which the failure plane is already defined. We have we already know that the failure takes place from this section only. But what are the significant of this test? What type of section? What type of soil? These result will be valuable, and is it more economical than other tests? Is it less time consuming than other tests? Those aspects will be we will taking over here. Okay. So first of all, the direct shear test carried out on the soil sample confined in a metal box. There is a apparatus also shown with one of the images in a subsequent slide will be shown to you. So it is confined in a middle box of the square cross section which is split horizontally at mid height. As I said that it is already have the predefined failure plane. So it its cross section with in a split horizontal at mid height is there, and a small clearance is maintained between the two half of the box. You must have gone across the video. Over there also there is a video is played, the NPTEL video. There you have seen that the sum of the you have seen that the sum of the sections are there, from which the predefined failure section you have seen, if you have gone through the video. The lecture number 6, I think so, of the NPTEL. The soil is sheared along perpendicular to the plane by moving the top half of the box relative to the bottom half, and the box usually is a square in plane of 60 mm into 60 mm, and it is not a prerequisite for the research purpose. The various researchers use the different dimension of the box for this test only. So that is the part of research. As of now, you will consider this only as the square incline. But for the research, the different box types are used. Now you see that over here, this is the apparatus showing the direct shear test. That is the box shear test, whatever you tell with the different names. So over here you can see that if you can see the cursor, you see that at the middle section there already a horizontal bisection has been seen. So when the load is applied, the failures already defined and take place from this value. Only we will come to know that what is the strength of soil at which load at what stresses the failures get takes place. So we will state that this much is the shear strength of this soil sections. This is the apparatus, and one of the homework for you, you can go in your lab and you can perform this test. You also, if the apparatus is not available with you, if some of you are the working professionals, so you can go on the YouTube. There also the demonstration is presented in a practical manner, so it will give you better aspects of this test. And I think so the NPTEL, similarly there is the NCTEL which will providing those aspects. That is over there also the IITs lab technicians are performing this test. So you will get the very good idea if you see the practical implementation of this test. So it is my suggestion. This is the homework for you. Please go with them. Okay. Now, what are the prerequisite conditions for this test? So, this what type of soil? Basically, we are talking about, say, is there any condition that what type of soil should be there? What is the water table conditions for performing this type of test? What type of soil should be used? So, those conditions we are discussing over here. So, if the soil sample is fully or partially saturated, the saturated perforated metal plates and the porous stones are placed below and above the sample to allow the free drainage. If it is a partially saturated, there must be water over there. So, for providing the drainage facility, we will provide some of the metal plates and the porous stones for allowing the water to flow down if during the test. So that will implement the practical implementation which is going to take place in the field as well. If now if the sample is dry, the solid metal plates are used, and there is no need of the perforated stones over there in order to provide the drainage facility. A load to the plane of shearing can be applied to the soil sample through a lead of box. So you have seen the last apparatus. The shear force, you have seen that shear force is written with the help of the weight. There is a section over here. Over there we will apply the sum of the load. We will apply get increasing the load term by term, and afterward you have seen that at specific load you will get slide off and soil get filled, and that will be the strength of the soil over there. So those aspects has been taken. Okay, and it is one of the most important thing you can perform very easily. It is not too difficult test, and but while when we go to try Excel test, that is also that aspects the performing those tests is difficult, and sometimes some tests are also too much time consuming as well. Okay. Now we will consider the sand and clay for the test, how it will affect the over there, that is that is considered. Okay, so first of all, the test on the sand and gravel can be performed quickly and are usually performed dry, as it is found that water does not significantly affect the drain strength. You have already know that sand and gravel has a good permeability, the water flow through them. So the uh, test on those are performed very quickly. While for clay, the rate of shearing must be chosen to prevent the excess pore water pressure building up. So those points need to be taken into consideration. Now we will move to the procedure of the test. So before moving to those points, I will suggest you that we will take a 5 minute break. After that, we will again start, and I will request you to please remain in the meeting. We will start at 4:05 again. Okay. Welcome back. Now we will start our discussion again after this break with the procedure of the direct shear test. So first of all, what are the steps we are going to follow during the direct shear test? We will go with that in a procedure. So as a vertical normal load is applied to the sample, the shear stress is gradually applied horizontally by causing the two halves of the box to move relative to each other. You have seen the schematic diagram for the direct shear test. There you have seen that the two halves are there. One is the upper half and another is the lower half. And in between there is a space is given that is the predefined shear failure planes. So as the load increased, as the normal load increased, so the gradually result in the horizontal movement, which will result in the failure of the soil over there, ultimately the movement of the box. So the shear load is measured together with the corresponding shear displacement, and the change of the thickness of the sample is also measured. The sample thickness also get changed because there is a normal load is applied at the top of the section. I will show you the schematic diagram after reading all those points or explaining all those points specifically, precisely. So a number of samples of soils are tested each other different vertical loads, and the values of the shear stress at the failure is plotted against the normal stress for each test. For every test, the different normal stress are applied, and corresponding to that, the shear stress is found. On those values, there is a diagram is plotted on a sigma tau graph. Provided that there is no excess pore water pressure in the soil, the total and the effective stress will be identical. We know that the effective stress is nothing but the total stress minus pore water pressure. If we consider there is a no pore water pressure, no excess pore water pressure will be there, then it will be concluded that if there is a no excess pore water is there, then the effective stress is nothing, that is the total stress one. From the stress at failure, the failure envelope can be obtained. After performing this test, we will able to get a envelope, that is the failure envelope, below which there is no failure take place, above which if some stress point get reached, the failure in soil takes place, that is the shear failure of soil that is considered. Moving on, I also saw the one of the schematic diagram which we already discussed. For your convenience, you will understand this point that the load is applied, the normal load is also applied. Due to normal load, there is a change in the thickness of the soil samples also takes place. The shear force is also there, that will result in the movement in the horizontal direction, ultimately lead to the failure of the soil, and the load at which this takes place is the shear strength of the soil. Okay, you will go. I will. What I will suggest, you must go with some of the demonstrations that will open your mind that how it is going taking place. Okay. So now we see the some of the advantage. What are the some of the advantage of this test? And we must understand that every test which we are performing either have some advantage or must have some disadvantage as well along with this. So first of all, we see that this test is very easy, and this test can be performed on sand and gravels both, and this test is one of the very simple test anyone can perform. There is no more sophisticated instrument is required for performing this type of test. The large sample can be tested in a large shear boxes, and small samples can be misleading the result due to the imperfections such as the fractures, features, or may not be truly representative. But that's not really the case. When we go on the research aspects, we consider the different types of boxes for the testing. Otherwise, we will not consider too much things. Uh, we will consider the specific box and we will test that only, but for the research purpose it will become very important that we will get the clear idea about the soil, that what is the shear stress. Basically on the basis of that we are going to state our result and that will be used by the other design engineers from your research. So that will become crucial. So over there we use the different type of boxes. Okay. The samples can be sheared along perpendicular to the plane when the shear strength along the features or others selected planes are needed. Now, the some of the advantages, as I already discussed, the main advantage is that is the it doesn't fail along the weakest plane. We already predefined the plane with which it must have to. There is the no aspect that it has the true failure plane. The failure plane is already decided. So first of all, I will explain those point to you that the failure planes is always horizontal in the test, and this may not be the weakest plane. As I already said, this is the very rare of the rare is that this is the weakest point. Might be this must maybe the weakest point, but we doesn't say that this is the weakest point from which the failure takes place. So the failure of the soil occurs progressively from edges toward the center of the soil. As you have seen that the failure moves from edge toward the soil when the sample gets filled, and there is the no provision of measuring the pore water pressure. As I already said, as it is already seen that in when the soil is partially saturated, there is a stone cobbles are used below the perforated steel sections. But so there is no provision to measure the pore water pressure. What is the pore water pressure dissipated? We couldn't measure. There is no mechanism present in the shear box test, and it is not possible to determine the effective stress as pore water is not we are not able to measure the pore water pressure, so it is next to impossible to get the value of the effective stress, because effective stress is nothing but the total stress minus the pore water pressure. If the pore water pressure calculation is not possible, so we are not able to determine the effective stress, so the it doesn't represent the shear strength in the very true sense in a way. But it is quite useful. It will be used at the several places. The shear box apparatus can give the reliable and drain distance because it is impossible to prevent the localized drainage away from the shear plane. So the shear box apparatus is not able to give the reliable and drain strength because the pore water pressure we are not going to able to measure. Now we move to the next test, that is the triaxial test. And in the triaxial test, what are the advantages we are getting over the direct shear test? What are the different aspects we are exploring will be seen. And this test is more or less close to the actual condition which is present in the soil. So this test is quite popular, but it is need some sophisticated instrument, and the person with some good knowledge can perform. Otherwise, the other test also require the technical person in order to their implementation. But this test is also sometimes time consuming as well, depending upon the type of the soil. So, but this test give the result of this test is quite promising. Okay, so first of all, we start with the test. Over here, the triaxial test is carried out in a cell on a cylindrical soil sample having the length to dia ratio is 2. The length to dia ratio is 2, that is, length is the 2 times of diameter. Normally, it has been seen that the apparatus of 76 into 38 and 100 into 50 is used. Over here, you also see that this is the length to dia ratio is 2:1. The three principal stresses are applied. As I have said that there is a radial stress and the axial stress. So in this case, we applied the three principal stresses applied on the soil sample, which implement the actual condition, out of which the two are applied water pressure inside the confining cells and are equal. And in actual also, what I had given the example, consider a soil section below the soil. The stress applied in the horizontal direction is almost same, or 90% of the time it will be same, but the axial stress will be different. So what we are going to measure here, Horizontal stress, that is the confining pressure sigma 3, remain same, and the sigma 1 get varied. On the basis of that, we are going to form the Mohr envelope as well, that we ultimately able to get and find the result for that. So the third principal stress is applied by the loading ram through the top on the cell, and it is known to be deviatoric stress. The different to the other two principal stress, a typical triaxial cell you can see in a coming slide which I am going to show. It is a schematic diagram, not the actual triaxial test apparatus. It is a schematic diagram. You can see that how the soil is present there, and in that section, when you see in the three dimension, the confining pressure is applied all around, and the geriatric stress is applied from the topward section. So the axial stress is different, but the radial stress is same all across. We have considered the three principal stresses. So the three in three perpendicular directions, the three stresses are getting acted, and how the cell pressure are controlled, the pore water pressure, backwater pressure, and the volume changes. You will come across in a theoretical part as well, but again, I will suggest you to perform this test at your institute. If you are a working professional, you don't have those access, so please go across the some of the demonstration at available at different platforms by the different persons. So you will get the practical idea, practical implementation, that how these things are we are getting, and how this result will be helpful for us in the practical knowledge. Okay, moving ahead, the test procedure. That again we will go with the test procedure for this test. That what is the process we are going to follow, how we are getting the results, and there are the different aspects are also there in triaxial test. The UU test, CU test, and CB test is there, and that is unconfined. Okay, I will tell you when it's taken, and we will not jump. We'll go step by step, so we'll get the better understanding. Okay. The soil sample is placed inside a rubber stage which is sealed to the top cap and the bottom and the pedestal by rubber ring. And the for test with the pore pressure measurement, the porous discs are placed at the bottom and sometimes at the top of the specimen. Filter paper, a filter paper drains may be provided around outside the specimen in order to speed up the consolidation process. As this process could be controlled, and the pore water pressure is also we are able to manage in a triaxial test. Okay, oh, it is also written over here that the pore water pressure generated inside the specimen during the testing can be measured by the means of the pressure transducers. So we are able to measure the what is the value of the pore pressure which is generated over here. Okay, I think so. You are getting my point. Moving ahead, there are the two stages in the triaxial test. So the triaxial test, compression test consists of the two stages. The first stage and second stage. What we are going to do in the first stage and what we are going to do in the second stage will be needed to be understood, and this is one of the important aspects in a triaxial test. So in this, a soil sample is set in a triaxial cell and the confining pressure is then applied. The confining pressure is applied all across, and the value is same, and it is applied mostly with the help of the water over there. In the second stage, additional axial stress also applied. The additional axial stress is applied from the top, and uh, that is also known as the deviatoric stress, which induces the shear stress in the sample, which ultimately basically the stress all across is already acting. When you apply another stress from the top, it will result in the shear. It will result in the shear between the soil sections. I think so. You are able to get those points, but I must suggest that you must see the demonstration if you are working professional. If you are a student at some institute, if equipments are available at your institute, must perform this test by your own. Okay, is applied and the axial stress is continuously increased until the sample gets filled, and the Afterwards, you will get the value of the diabatic stress. The confining pressure which we applied is already known to us. After interrelating those terms, there is an interrelation like sigma 1 equal to sigma 3 times per 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, which we are going to see. That will that will, with the help of that, we are able to find the value of the what is the shear strength, what is the sigma 1, what is the sigma 3, what is the shear strength parameter, that is C and phi, that will ultimately result in the found help in getting the value of the shear strength, that is S equal to C plus sigma and tan phi. Now, one of the most important things which is that is that during both the stages, the applied stress, axial strain, and the pore water pressure or the change in the sample volume can be measured. So here it is clearly mentioned that we can able to get the value of the pore water pressure. So as we have seen that in the direct shear test, where we are able to find the pore water pressure, the answer is no. The pore water pressure calculation is not possible in those cases like direct shear test, but here we can able to get the pore water pressure. Now come across the types of test. We have the primarily three types of test. That is the unconsolidated undrained test, that is UU test. In this test, the cell pressure is applied without allowing drainage. Unconsolidated undrained. Clear from the name, in both the stages, the valves are remain closed. There is the no drainage is allowed, and keeping the oil cell at constant, and then the abiotic stress is applied to the failure without drainage. And this is one of the tests which take place a little faster in this. And when you came across the water is not moving out, so you will get the values more precisely. Over here, you get the total stress parameter. CU consolidation undrained test, we will going to discuss the total stress and effective stress parameter in the subsequent slides. So CU consolidation undrained test, in this the drainage is allowed during the cell pressure application. Then without allowing the further drainage, the diabatic stress is increased, keeping the cell pressure constant. Okay, I will explain this point again for you that in this case, the valves are remain open as the drainage allowed during the cell pressure application. Means during the first stage, the water is allowed to move out. But when we move into the second stage, when the diabatic stress is applied, in that case, the drainage is not allowed. Now the valve is closed, and then the vertical stress is applied, and that will result in ultimately result in the failure, and we will get the value of this diabatic stress, and the confining pressure is already known to us. So at what diabatic stress the failure takes place, we will able to get. And the Mohr failure envelope which you have seen is also drawn with the help of the value of sigma 1 and sigma 3. In that case, the sigma 3 is already known. Then we apply a stress, we get some value of sigma 1. We draw that circle. After that, we apply the different sigma 3 value. On the basis of that, on the application of that sigma 3 value, the diabatic stress is known, and diabatic stress is nothing but sigma 1 minus sigma 3. So when the diabatic stress get known, you get the value of sigma 1, the another circle is drawn, then again you change the value of sigma 3, and again you apply the diabatic stress, you will get the value of the sigma 3 for that as well. Afterward, you draw a tangent, common tangent to all the circle, and that common tangent is the failure envelope which is shown. And when you extend this to the backward side, the what it make angle with the horizontal is the value of angle of internal friction, and where it cut the shear stress axis is the cohesion, in a way that we will discuss in a elaborate way in a coming section. Okay. Now we came across the consolidated drain test. As clear from the name, in this case the drainage is allowed in both the stages, like the first stage and the second stage as well. So it is similar to the consolidated and drain test, except the diabatic stress is increased. Drainage is permitted, and the rate of loading must be slow enough to ensure the no excess pore water pressure development. and we have to concern that no excess pore water pressure get developed over here. So that consideration need to be taken care of. Now we will see that what is the significance we are getting with the help of the triaxial test. That the first stage simulate the laboratory in situ condition of the soil and, of the soil and at a different depth is subjected to the different effective stresses. The consolidation will occur if the pore water pressure which develop upon the application of the confined pressure is allowed to dissipate. Otherwise, the another thing also you will understand that we are able to get the pore water pressure. As we are able to get the value of pore water pressure, we are able to get the effective stress. As effective stress is the total stress minus pore water pressure. So we are able to get those things as well, which we are not able to get during the direct shear test. I think so. That is very clear. Now we will move ahead, and when we go ahead, we will see. Okay, give me a minute. No. Now, the some of the more points significance is like that during the shearing process, the soil sample experience the axial strain. Obviously, either the volume change or the development of the pore water pressure occur, and the magnitude of the shear stress acting on the different plane in soil sample is different, obviously different. And when at some extent the sample phase limiting the shear stress on the failure plane is called the shear strain. Actually, you will come to know that the magnitude of shear stress acting at the different plane in a soil sample, they consider there is a soil sample is there, but at different plane, the magnitude of shear stress get act, and that will be different for the different plane. We also know that if we see the soil sample at different planes in soil sample, the different stress is there. It is already known to you. So, in at some extent, the sample space this limiting shear stress on the failure plane is the called the shear strength. The plane on which soil gets filled. So here one another point you will see that there is a no predefined failure plane. As in the direct shear test, we already know that the soil gets filled from this section only. But in this case, there is a no defined failure plane. We haven't decided that the soil need to be filled from this section only. It will fail where it is reach at the critical combination where it has exceeded the critical shear strength, that is the weakest plane is found and it fails from its weakest plane only. So it represents the actual presentation of the failure of the soil. Okay. Now, what are the advantage over the direct shear test? Some of it also have. I already said. I said that several occasions that it has the more advantages as compared to direct shear test. So, what are those advantages? And we also have to understand that what are the advantages we are talking about. So the soil samples are subjected to uniform stress and strain. Over here, you understood that in this case, the confining pressure acted from all the directions, so there is a uniform stress is there and uniform strain is there. The different combination of the confining and axial stress can be applied. I already said that we apply a sigma 3, we found the deviatic stress. Then we again apply some other sigma 3, other confining pressure, we found the sigma D, and sigma D equal to sigma 1 minus sigma 3, that we will be going to taking into consideration afterwards when we are going to solve some problems. So sigma D is the sigma 1 minus sigma 3. So ultimately you are getting the value of the sigma 1, and you will find the value of sigma 1 and sigma 3 on the value of basis of sigma 1 and sigma 3. You already know the Mohr circle. So you are able to draw the various circles for different sigma 3, different sigma 1 you get, and on drawing a common tangent you will get the failure in value. Okay. Now, drained and undrained test can be carried out over here. In direct shear test, no consideration is there. There is no facility to get the pore water pressure, so the drained and undrained conditions, weak current control. Now, the pore water pressure can be measured in the undrained test. and the complete stress strain behavior can be determined during the triaxial test. There is no limitation like those are present in the diaxial test. Okay. Moving ahead, when we go ahead, we will see that the total stress parameter. Here you see that the three circles are drawn. In UU test, you see that the three circles are drawn and there is no drainage allowed in the both the cases, so the no pore water pressure distribution takes place. Here you see that first of all a specific value of sigma 3 is applied, and on the basis of that the axial stress is applied. On the application of axial stress you get the value of sigma d, and sigma d is the sigma 1 minus sigma 3. Ultimately you get the value of sigma 1 and you draw a Mohr circle. Now you apply the value of sigma 3 as sigma 3 dash in the test 2, which is represented here. On application of sigma 3 dash, again you find the value of deviatoric stress. On the basis of that, you are able to get the value of sigma 1 dash. Again, you draw the circle. When you perform this test, UU test, you find that all the circle of the same diameter gets formed, and it will, when we draw a common tangent to that, it will be a horizontal line, it will be parallel to the horizontal axis, so it represents that there is no angle with the horizontal, so it high value is 0, and whatever the value, wherever the tangent get cut on the y-axis or axis, the value is nothing but the cohesion over there. Okay, moving ahead, and I will read some point for you. I think so. Those points are only written over here. That all Mohr circle of the U test plotted in the term of total stress have the same diameter. The Mohr failure envelope is horizontal straight line. Hence, the friction value is zero, and it can be represented by the equation that is tau f equal to sigma 1 minus sigma 3 by 2. It is already understood by us. There is no confusion when we rate the Mohr circle. These terms we have taken into account. We found the value of sigma 1 minus sigma 3, that we are seeing the radius of the Mohr circle. Okay. Now, in CU and CD test, when we are performing the confined consolidated drain test and consolidated drain test, over there you will find that you apply the value of sigma 3, you will get the value of sigma 1. Afterwards, when you change the value of sigma 3 and even you then you find some other value of sigma 1, on drawing the tangent to that circle, you doesn't get a straight line parallel to x-axis, you get the this type of things over here. The value of friction and value of cohesion both is found, but in both the cases the value of cohesion from consolidated undrained test and consolidated drain test will be different, because in consolidated drain test, the effective stress parameter we are getting, the drainage is allowed in both the cases, so the value of cohesion get we got in that cases will be different from the consolidated undrained test. So first of all, we will found that what are the aspects which are here. So the for the test involving the drainage in the first stage, when the Mohr circle are plotted in terms of the total stress, the diameter increases with the confining pressure, and the resulting failure envelope can be inclined line with the intersect on a horizontal axis. Obviously, it has been seen in the graph picture as well. It is also observed that the cohesion in the consolidated undrained and cohesion in the consolidated drain are not similar. Similarly, the friction value in the consolidated undrained and consolidated drains are also not found to be same. So it is easily stated that for the identification of the soil sample tested under the different triaxial condition like UU on consolidated and drain, and the consolidated drain test, the failure envelope is not unique, because in all the three conditions we have provided the different drainage consideration. In first case, the drainage is not allowed in both the stages. In the second case, drainage is not allowed in the second case, while in the third case, like CD test, the drainage is allowed in both the stages. So the value of the cohesion and friction will be different, but ultimately when you going to find the value of the shear strength, you will get the same from all the three cases. But there is another aspect, you cannot apply all the cases everywhere. You should look into that. Now, we will move to the effective stress parameter. When we are talking about the effective stress parameter, is the same triaxial test result of the UUCUs and CD are plotted in terms of the effective stress taking into the consideration the measured pore water pressure. It is observed that all the Mohr circle at the failure are tangent to the same failure envelope, indicating the shear strength parameter and the unique friction of the effective strain on the failure plane. So the question arises, why it takes place? Basically, in these cases, we have considered the effective stress parameter. In UU test, the pore water pressure get is considered, and in both the cases, the pore water is subtracted. So ultimately, we are getting the effective stress parameter, effective parameter C dash and phi dash. That's why the failure envelope remain common for all the three cases, because here the effective stress parameter is considered and effective stress parameter remains same for all the three cases, because in earlier we are considering total stress, and when the drainage is allowed, there we get the effective stress. So the result for that case will never be same for the total stress parameter, and effective stress parameter is a different thing. So you must understand that when we are considering the effective stress parameter, the result for all the three tests will indicating the same failure envelope, irrespective of when we calculate the total stress parameter, the value will be quite different. Okay. Now moving ahead, when we know that the failure envelope in the shear strength envelope may be written as tau f equal to c dash plus sigma dash tan phi. We have already started our discussion from here only, like shear strength is the value that is equal to the cohesion plus effective stress into tan into friction angle. So that is we ultimately reach to that point where we can say this relation, where c dash is the cohesion intercept in term of effective stress. Excuse me. Pi dash is the angle of shearing resistance in terms of effective stress, and sigma n dash is the effective stress parameter which already explained, and here tau is the shear stress on the same plane. Okay. Now some interrelation which I already state you, but here the interrelation is written like sigma 1 equal to sigma 3 dash 1 plus sin phi by 1 minus sin phi plus 2c dash 1 plus sin phi by 1 minus sin. It can also be written as sigma 1 dash equal to sigma 3 tan square 45 plus phi by 2 plus 2c tan 45 plus phi by 2. That relation I mistakenly forget to write over here, but those relation are also there, and it is nothing but the same. If you are expert in trigonometry, you solve n 1 plus n phi by 1 minus n phi, you will get sigma 3 dash tan square 45 plus phi by 2, and that's not the problem with you, I think. So you will able to get those points. Similarly, 2c tan 45 plus phi by 2, basically that is nothing but root under that only, so tan 45 plus phi by 2 only. Okay. Moving ahead, the pore water pressure parameter. So now we are talking about the pore water pressure parameter. Here the Scampton parameter, like A and B, the two factors are there. We are going to discuss in this section. So the pore water pressure parameter. The difference between the total and the effective stress is simply the pore water pressure U. We already know that. And the total stress and effective stress Mohr circle have the same diameter and are only separated along the sigma axis. In total stress, the value of sigma will be different, and the magnitude of the pore water. This is happened due to the magnitude of pore water pressure. So it is easy to construct a series of total stress Mohr circle, but inferred total stress parameter have no relevance to the actual soil behavior. And in the principle, the effective shear strength parameter are necessary to check the stability against the failure for any soil construction in the field. And to do this, the pore water pressure in the ground under the changed loading condition must be known. and is generally in general they are not. So it will be the important point that the pore water pressure parameter will become one of the important term. With the help of this, we will come to know that what are the total pore water pressure get generated during the process. This is also one of the problem which can be asked during the examination, or if you are appearing in any of the competitive exam, the scamming pore water pressure parameter become most important. There is some interrelations are there which is coming in next slide, in the subsequent slide, not next slide. So in the undrained triaxial test with the pore pressure measurement, this is possible and the effective stress can then be determined. Alternatively, in a drain test, the loading rate can be made sufficiently slow so as to allow the dissipation of the all axis pore water pressure. For the low permeability, soil and drainage will require the longer time. Exactly. It can be seen that if the soil have less permeability, so the drainage times absolutely get increased. There is no problem with that for anyone, I think. Moving ahead, in a undrained test, the general expression relating the total pore water pressure developing and changing in applied stress for the both stages is delta U equal to delta U1 plus delta U2. Now the delta U1 is the change during the stage 1 while U2 is stage 2. So how we will calculate? Is nothing but B into delta sigma 3 plus dA into delta sigma 1 minus sigma 3. Now I will tell you another aspect like when we interrelate when we will transform this function it becomes b into delta sigma 3 plus delta a into delta sigma 1 minus delta sigma 3. Here delta u1 is the pore water pressure developed at the first stage uh, during the application of confining stage. Basically, if you want to calculate the value of B, that is nothing but delta sigma 3 the change in the pressure during the confining stage. While delta U2 is the pore water pressure developed during the second stage, when the stress is delta sigma 1 minus delta sigma 3. And these B and E are the Scampton pore water pressure parameter. So it become one of the important term and sometimes problems are also asked from here. And the parameter B which is depend on the confining stage is one of the term whose value remain one whose values remain one for the saturated soil and zero for the dry soil. Similarly, if we talk about the parameter E, is also not constant, it varies with the for over concentration ratio. Now, question arises, what is over concentration ratio? You must be aware about that, but if not, I will explain this term to you. That the stress applied in the past, it is the ratio of stress applied in the past to the stress applied in the present. So the parameter A not remain constant. Over concentration it varies with the over concentration ratio of the soil. Also varies for the magnitude of the derivative stress. The value of A, the value of Scampton parameter A at failure is necessary in plotting the effective stress Mohr circle. Moving ahead, when we consider a behavior of the saturated soil sample in the undrained triaxial test, in the first stage, the increase in the cell pressure without allowing the drainage has effect of increasing the pore pressure by the same amount. Basically, when you see that, specifically during the undrained test, when water is not allowed to move on a saturated soil sample, the in first stage when cell pressure is increased and water is not allowed to flow out, the pore water pressure get increased by same amount because there is no drainage facility available. So the all the pressure which is generated is transforming into the pore water pressure only. and no change in the effective stress also takes place because all the changing transform into pore water pressure, the stress which is already there it remains same because pore water pressure is calculated, so effective stress remains same. During the second shearing stage, the change in the pore water pressure can either be positive or negative because of the drainage condition. Okay. Now, for UU test, the saturated soil, the pore water pressure is not dissipated in both the stages, like delta U is equal to delta U1 plus delta U2. Similarly, because you know that in UU test in both the stages, the valve remain closed, the no water dissipation is allowed, volume remain constant. Similarly, for the CO test on the saturated soil, the pore water pressure is not dissipated in the second condition, second stage. So delta U is nothing but delta U2 only because the water is not allowed to move out during the second stage. So the pore water pressure in the first stage the water get dissipated, but in the second stage the pore water pressure is calculated. The first stage water is allowed to move on, so there is no pore water pressure over there. Okay, so that's why the value of pore water pressure is only delta U2, not delta U1 for the CU test. Moving ahead, now the stress strain behavior of sand. So sand is usually sheared under the drain condition. We know about the void ratio. That void ratio is the one of the important aspects. Volume of void by volume of solid. Okay, so it is related to solid, so we tell it important aspects, but it is in a cohesive soil. But in the cohesionless soil, the relative density becomes the most important term, which is used to relate. We say that on the basis of relative density, that what is the value, what is the which soil is the loose or dense, we can also consider about that because it relates the void maximum and minimum void ratio as well along with the void ratio in the given condition. So the sand are usually sheared under the drained condition as they have relatively higher permeability. This behavior can be investigated in the direct shear or the triaxial test. The two most important parameters governing their behavior are relative density and the magnitude of effective stress. Relative density, how we calculate the relative density? Relative density is equal to Emax minus E by Emax minus E. And you must understood that the value of Emax is 0.91 while the Emin is 0.35. No, normally we will remember this, but not it is always the value of Emax and Emin will be this only. But for any examination purpose, this will be given over there as well. Now, so the where E is the void ratio in the present situation. In a current situation, what is the value of void ratio is the value of E. Now, we can also relate this term with the help with the gamma D, the dry density. So, it will be related with the gamma D as gamma D minus gamma D mean by gamma D max minus gamma D mean into gamma D max by gamma D into 100 because it is a percentage, so it is multiplied by 100. You can also relate to volume as V max minus V by V max minus V mean into 100. So there are the various correlations which is exist to found the relative density, but primarily we use the void ratio, either void ratio or the dye density. So these two aspects you need to be remember because there are several problems get framed during the examination as well on the basis of that. Maybe framed, must not. Okay. Now the as I already said that the relative density is one of the important aspects. If the relative density is more than 65%, then it is said to be dense, while if the relative density is less than 35%, it is loose. So it is also aspects by which we differentiate whether the several soil is called to be dense or to be loose. Okay. Moving ahead, this is the dense, medium, and loose soils representation will be presented with the deviating stress. The deviating stress is sigma D, that is sigma 1 minus sigma 3, and the axial strain on the x-axis. And the variation of volumetric strain and the void ratio is also plotted over here. In this case, the influence of the relative density on the behavior of saturated sand can be seen from the plot of the consolidated drain test that is performed at the several effective confining stress, there would be no induced pore water pressure existing in the sample. So over here you can see that the dense sand, there is a point seen at the top sections from where it get losing its strength. So axial strain after get increased after the application of less derivative stress as well. So there is a clear failure planes has been seen in a dense sand, but in a loose sand, there is a progressive graph is going progressively. So there is no clear determination that where the failure takes place. So this is the different aspects. In a dense sand, with the help of relative density, with the help of relative density, we will say that this is a dense sand. Sorry. Okay. So similarly, the volumetric strain representation is also shown that in a dense sand, first of all, the volumetric strain get negative. Afterward, it get in a positive direction. While in the loose sand, the volumetric strain always go progressively, it increases from its initial point toward the end. Similarly, if we see the void ratio variation, so we see that the loose and dense both void ratio ultimately move toward the medium section, meaning the medium density soil, medium soil, neither loose nor dense. Okay. Moving ahead, for the dense sand, for the dense sand sample, the deviatoric stress reaches a peak at the low value of the axial strain. Exactly, it has been seen from the last graph, and then drop down where for the loose sand, the sample, the deviatoric stress build up gradually with the axial strain, and the behavior of the medium sample is in between, which is shown from the last graph. The following more observation could be made out from those graphs as well. So what are the observations? So we will see that now you can see that all samples approaching the same ultimate condition of the shear stress. Exactly. If you go in the last image, all the sample ultimately reach in a same condition. Either it is a loose, it is a dense, or it is a medium. So, irrespective of their initial density, and the denser sample attains higher peak angle of the shearing resistance in between. Initially, dense sample expand or dilate when sheared, and initially loose sample compress. So, this is the term. Now we will solve some of the problems, some of the small problems before ending our today's session. So, let's look into the problem. So, first of the problem is that there is a UU test is carried out on a saturated normally concentrated clay sample at the confining pressure of 3 kg per cm square. This 3 kg per cm square is nothing but sigma 3. The confining pressure which is acting all around is the value of 3 kg sum per cm square. The deviatoric stress at failure is 1 kg per cm square. The deviatoric stress, the stress which is applied up to, from the axial direction is the axial stress. So over here you can see that you have to find the value of total strength, stress strength parameter, and the another question is if the another identical sample is tested for the confining pressure of 4, means sigma 3 changes to 4 kg per cm square, what will be the vertical axial stress at the failure? So we will solve this problem here. So look into that. So first of all, there is a graph is plotted as it is a UU test. So we already see that the graph is plotted this way only. Now the sigma 3 is 3 kg per cm square and sigma d is 1 kg per cm square, and I already said that the deviatoric stress is nothing but sigma 1 minus sigma 3. So here you can see that the sigma 1 minus sigma 3 is 1 kg per cm square, and from the plot you see that the phi uu is equal to 0. So C uu is equal to sigma 1 minus sigma 3 by 2, that is the 0.5 kg per cm square. Similarly, when you try to find the second part of the problem where given that sigma 3f equal to 4 and you test identical sample, the failure is performed. So the sigma 1 minus sigma 3f at all the confining pressure. Therefore, the vertical axial stress at the failure become the sigma 1f equal to sigma 3 plus deviatric. So the value becomes sigma 1f is equal to 5 kg per cm square. Moving to the second problem, that is over here also the confining pressure is given, the axial stress at the failure is given, that is the geometric stress is given, and the pore water pressure failure parameter is also given. In this case also we have to find the value. So for this problem, you again see sigma 3 dash equal to sigma 3 minus sigma f because effective stress parameter we are considering. So sigma 3 value is 4.8 and the pore water pressure developed during for the sample 1 is 3.8, to sigma 3 dash is 1 while sigma 1 dash is 3. Similarly for from that table only. And for sample 2 also we are getting the effective stress parameter, and after the plot from the plot we when we plot this point 1 and 3 and 1.5 and 4.5, we come to know that this graph get plotted, and on the basis of that the value of cohesion remains 0, while when we measure this angle we get the value of phi h 30 degree. We can also find this value with the help of empirical relation, that is sigma 1 equal to sigma 3. Whatever you see over there, that 1 plus sin phi by 1 minus sin phi plus 2c root under 1 plus sin phi by 1 minus sin phi. From that relation also we can get the value of the result, but over here so some of the data are not present. So from this data we have to get the answer with the help of this type of plots only. But today I haven't taken more problem for your convenience. From the next class, I will take the more problem that will represent your practical implementation of the whatever we are studying right now. So moving ahead, now we will discuss. Now I will suggest that what we are discussed today is the we understood the direct shear test. What is the procedure? What are the advantages? What are the disadvantages? What are the problem with that? That is the drainage condition. We are not able to maintain. We are not able to calculate the pore water pressure. So whether in the drained or undrained condition, what are the result is there? We are not able to understood. So those aspects are there. Another thing which we understood is the we performed the studied the triaxial test as well. Now some of the work I suggest you to do at your home that will help you in understanding these things. We understood that what is the shear strength, when shear strength takes place. So try to write some points that what is the shear strength, what do you mean by shear strength, how shear strength affect the soil, whether the shear strength is important aspects in what places, what we have seen that in the foundation design, in the slope stability, in the retaining wall, the shear strength become one of the more important parameter. Similarly, I also suggest you to write the procedure which we already discussed as well, and I suggest you to see the demonstration or perform the demonstration. On the basis of that, write the procedure in your own language. It will enhance your thinking capability and understanding capability about the practical test stage. I also suggest you to at least see the demonstration of tri-axle test if you are not able to perform. And another important point I want to mention, to stay in the motivated way to learn the new things. And these are the references from where I have referred the content for today's discussion. So I think so time also get offered. So with this, I will end the today's session because I think so meeting may get automatically closed. So I don't want such situation to appear. So I will end the meeting. There are no. So thank you everyone for joining, and I think this meeting will help you to some extent. I will suggest you to go ahead with this point, solve some problems on the basis of today's discussion, and I will come to you in the next lecture with some new problems, some new concept. which will be discussed during this week with you. And with this, I will wind up the session. Uh, Wish you a very happy weekend. Thank you, everyone.